In this video, we're going to carry on with our Ferrari fender one more time, and we're going to build the bottom portion of the fender using Fusion 360 surfaces. Hey everyone, this is Matt with Learn Everything About Design, and in this video, we're going to carry on with this fender one more time. And I know I said that in the last video, I wasn't planning on going any further with it. But I have seen several comments. People have requested that I do a little bit more with this because I think in general, this is a very applicable use for surfacing. So we are going to carry on with this one more time, and we're going to talk about building out the lower portion of the fender using what we have. And the reason that I want to carry this on is because I want to talk about ways in which we can use our 3D sketches or our splines and build out the remaining portions of this fender. Now at this point, there's a lot of surfaces inside of the browser. And if you go to the description of the video, you can carry on with this video. And let's just note a few things that we have here. We've got the original midline piece, which we are going to be using. We've got the small sections that we used originally to build out the portion of the fender lip. We've got a body where we used a patch surface and we filleted those together. We've got body 11, which has the lofted portions between those edges. And then we've got this other body here, which we used or we created using the 3D spline in a single sketch. So we're going to carry on with body 11. This is the one that we had. Basically, we used a loft to go between one edge and the other. And the reason that we're going to do this is because I want to carry on using that midline. And the midline is going to be important to us because we want to use that as our reference going down to the lower portion of the fender. So we're going to start with the back section. I want to go into my sketches and I want to find the sketch that I used to trim out the opening. Now at this point it can be pretty difficult because if we go back through these sketches, we might not necessarily know which sketch it is. In this case, sketch 16 has the original curves. And what I want to do is I want to cut out this inside portion here. And the reason I want to do that is because I'm going to focus on the back section here as one piece and the front section as one, because the front is actually slightly difficult because of the way that the geometry is created here. So we're going to have to take a little extra care there. So I want to use this as a trim tool. So we'll go to our surfaces, trim. The trim tool is going to be that inside arc, and then we're just going to remove this inside piece. We're not going to need this surface anymore after this, so we don't need to worry about maintaining a copy of it. The next thing that we want to do is we want to remember that the midline of this car, this is actually a recessed or sunken in section. So we're not worried about carrying the curvature from the upper portion of the fender to the lower, but that's why we saved this extra piece here. We overbuilt the original fender so that way we would have this as a reference. So we're going to carry this edge down and we're going to follow the straight line, even though I know that's not the door seam. It doesn't necessarily matter when you're building out a car. So the front section is tricky because we will need to trim some of this away, and we didn't perfectly follow the curvature of the car, but that's okay because we're not going to be too worried about that. But we are going to talk about how we can build out this front lip section because this piece here actually rolls. It's not a hard edge, it's just very smooth and gradual on the car, but it does roll forward. So we're going to take a look at how we can try to accomplish that. But let's get started by sketching on the back side. So we're going to start a new sketch. Just pick any sketch plane you want and enable your 3D sketch. When we do this, we want to include some 3D geometry. So from Create, Project Include, select Include 3D Geometry. And we want to select the edges of our midline surface. I'm going to right click and OK. Then I'm going to create a spline. I'm going to try to snap to that point. You'll notice that it's not snapping to those points here. If I rotate this around, I need to rotate it just slightly in 3D, and I'm just going to bring this line down, say OK. We'll do the same thing here, bring it down, and say OK. So if we rotate this around to the front, what we should see is that those go straight down, because even though we're sketching in 3D, it's going to assume that it's going to be planar unless we snap to a reference. So that's why we needed to snap to those points first. I'm going to hit Escape to get off my spline tool, and I'm going to build this all the way down to the bottom, even though this portion here is where the door opens. This is the sort of the break point between the front fender and the sill. And the sill on this car is going to be a separate piece. It's well, it's part of the body, but it's going to have its own little change in curvature. We're not going to worry about it for this example. That's not really the point of what we're doing here. But we do want to move these points down, and because we're in 3D, we can't just grab and move them like we can in a 2D sketch. We need to use Move Copy, which is M on the keyboard, and that allows me to move it. Once again, when we're using Move Copy, these handles right here, we need to activate the handle, and then we can use the Move Copy on the handle itself. The one on the back is not really going to be too much of a problem. Right-click and say OK. And next we want to give tangency to the spline relative to that 3D curve, and we're going to do the same thing over here. Even though this is vertical, I want to make sure that I do still maintain that. Hit Escape to get off our constraint. We're going to rotate this around to the front. I'm going to hide my canvas for now. I don't really need to see it. But I want to take both of these points and I want to move them inward. So I'm going to select them, say move, and I'm just going to pull them in a little bit. And you'll notice how this messes up the splines. It messes up the curvature. Now what happened here is the spline that we activated the handle is going vertically because it was activated and it was in plane. It was basically just a 2D plane that was offset from the original origin. So this means that I need to use Move Copy and I need to change the curvature of that. Now what I'm looking for is to get a nice gradual transition here. Hit Escape. Actually, let's go ahead, hit Move on that. And here is where I really dislike doing this in 3D. I'm going to go ahead and move that around. Then we'll have to say OK. The one that we didn't activate the handle on, that's essentially a vertical line, that one is essentially fine because it's going the path of least resistance. So essentially when you think about splines, if you don't activate a handle, it's going to try to invoke the curvature throughout the entire thing. We do want to make sure that these are essentially horizontal with each other. It doesn't have to be perfect, but I want to get them relatively close. I'm going to say OK. I'm going to select this back one. I'm going to activate the handle, and I'm going to say move. And you can see that it's going to move the entire thing. But then what I want to do is I want to move that to the handle itself. Right-click and say OK. Select the handle, one of them, and then hit move. And now I can move the handle around. So again, we're just looking to get them relatively close. From the side here, it looks pretty good. And again, we don't have to worry too much about it being a perfect line, but you'll notice that when I try to use the line tool in plane, it's not letting me select those. If I rotate it slightly, it will let me create a line between those 2 points. That line is not going to be horizontal. If I try to use a horizontal constraint, you can see now it's added that horizontal constraint and those handles are active. If I look at it from the front, that line or those 2 points should be in a perfect line with the y-axis now. So that looks pretty good. And what I want to do from here is finish my sketch. We can try to use a patch. We can turn off our enabled chaining, grab the bottom edge of this surface, and then grab each of these 3D splines. And then for this edge, we can use tangency. And because the 3D splines have tangency with the edges, with the project or the 3D included edges, then we should not have any problem maintaining that curvature. So we can say OK, and now we've built out a 3D surface. Then what we can do is take this piece and we can either offset it. Now the problem with offsetting, and I'll show you this as we look at it from the front, the problem with offsetting is it's going to go the direction of curvature. In this instance, because that upper edge is vertical, the tangency was vertical, it's not going to make too much of a difference for us. But usually a better option is to select that surface, use Move Copy, and move it directly in the X direction. Now the reason that that's a better option is because we can control which direction that's going. You also can do things like create a ruled surface off of these edges toward a direction. In our case, what we're going to do is we're going to create a loft going from these 3 edges, which should be connected, to this edge here. We're going to say OK. Right-click and repeat that, and now we're going to go from one edge to the other, say OK, and we've sort of built out that little recess that we see on the body. So again, that little piece that we kept, it was important because we needed it for the curvature, but also now we are able to simply build out that little piece that is going to be recessed in the body. That part was the easy part. The front part is where things get a little tricky. Now we have to follow the same process, but first let's go ahead and trim the front of this. And to do this, I'm going to use a 2D sketch. The 3D sketch option can be on, that's okay. But in this instance, what I want to do is I just want to make a spline that's going to allow me to sort of cut this. And because it's still in 2D, I can go ahead and manipulate the handles and then use it as a trim tool. I'm going to get rid of both of these front pieces. That allows me to use that sketch and ensure that I do have curvature, continuity, or tangency as we go across that trim. Okay, so again, we didn't perfectly build this because that front section of the fender is actually going to roll over and under the car. Again, the intent is not to perfectly model this car. The intent was to talk about how we can use our surface tools. So what we want to do is we want to just build out the fender, and we want to think about the way in which we do this. Now, there is a stylized line here depending on the year and the bumper that's included on the 308. There are different versions of this. This is a pretty rare bumper, I think. I think most of the ones you see have a lower front lip, a lower front bumper. And it's a little bit harder to find reference pictures of this, so you have to do a little bit of digging around. Just search online for Ferrari 308, anything from the 60s or the 70s, like probably 75, 76 is probably about where you're going to see this. But what we want to do is we want to build out that shape, and we're going to try to do it in 3D. Now, oftentimes what I'll do with something like a bumper like this is I'll build out this lower section where I want it all the way to the midline. So I start here and I sort of build it forward. It gets a little bit tricky to do, but that is one method. The method that we're going to take is we're going to try to build this out with 3D curves and see if we could just get it in one shot. It's usually pretty difficult, but we're going to try to do it. So once again, create a sketch. It's going to be a 3D sketch, so make sure in your sketch palette that option is turned on. Again, we're going to go to Include 3D Geometry. We're going to grab the edges of the surfaces that we're interested in, right-click and say OK. Now, once again, I'm going to build out a spline. We have to rotate this slightly, and I'm just going to build a spline that's essentially vertical. We're going to do the same thing over here. Remember, again, that when we're doing this in 3D, we'll need to rotate the view slightly in order to snap to those points. Why, I don't really know, but that's just how it is. Hit Escape to get off the spline tool, and then we're going to use M to move this point where we need it. So I'm going to move it here. I'm going to do the same thing back here. I'm going to move this point, right-click, and say OK. I'm going to add tangency. We're going to do the same thing up front. So that starts to drive the directions a little bit. Right-click and say OK. And then I'm going to rotate this around to the front. So from the front, you can see that the blueprint doesn't really match. This curve where we built it is a lot lower than what we see on the image. So again, we're not going to do this perfectly because the references that we have aren't super great, but we're going to use our move tool and we're going to sort of pull this in. The front lip or the front bumper generally is going to wrap under a bit farther than most of the other geometry, so we're going to sort of make that pretty apparent here. We want to make sure that the curvature looks okay, and when we look at it from the front and the side, that is going to be what we're expecting. So I'm going to turn the canvas on. I'm going to create another spline. Again, rotate slightly. I'm just going to go from here to here, say OK. From the right, it's going to look essentially like a straight line. That's not what we want. So we want to make sure that we activate this handle and that we change the curvature. We want it to essentially look like that shape that we're seeing. The other thing that we need to do is we need to figure out how we can get this front lip here and a guide curve to help drive the shape of this. In order to do that, we're going to select the spline, right-click, and insert a point. I'm going to put a point there. I'm going to right-click and say OK. I'm going to select the spline on the back, right-click, insert a point, and I'm going to once again put a point there, say OK. So these points are going to represent where the curve is that's driving that lip. Once again, I'm going to turn the canvas off. I'm going to select both of these points at the same time, move, and I'm going to pull those points inward. Now you can see what it's doing to the rest of the curvature because we haven't activated any handles here. And it's always important to minimize the amount of tension that you're putting on these splines. So if you are trying to build this out with the same method, having all of these different spline points internal and activating them makes it much harder for you to build out these surfaces. So in this case, I wanted to be very careful and mindful of that shape. I'm going to create a spline. I'm going to go from here to here, which is, again, essentially a straight line. I'm going to look at this from the bottom and hit escape to get off my spline tool. And then again, we need to think about, is this a straight line or does it have some sort of curvature to it? So as we rotate this around, this bottom edge, I'm going to activate that back point on the handle, and I'm going to change the curvature so it gradually arcs inward. And then the extra spline, I'm going to click on the handle, move copy, right click. We want to try to just move it a little bit and maybe try to activate it and hit escape. This is the problem we run into with these 3D splines. They really do not like to be moved in this way. So you have to, it's a little finicky. You just have to kind of get used to it. If anybody has a better way, please let me know. This is kind of always the way that I've had to do it, is sort of grab them, move them a little bit, and then activate that handle if it hasn't already been activated. Let's go ahead and look at this from a right view. We can see now this is not looking great. We need to make some adjustments. So once again, do a little bit of tweaking here. They look relatively close. Okay. So not ideal, probably not perfect, but let's just see what it looks like. So we're going to create a loft. I'm going to go from this back curve to this front curve. And then for my rails, I'm going to grab that top edge, which we can have tangency with. Then I'm going to grab these interior rails. So for the top edge, that rail that we have here, I can have a tangency constraint, and I can say OK. So that builds out that extra piece. This piece here, again, I'm going to move it. So move. Notice that when I move it and it's selected, it's trying to move it in a different direction. We're going to reset the pivot point, and we can do this by enabling the origin. We can select the origin and then the green check mark. What that allows us to do is it allows us to use the origin direction. Then I can move this in. In this case, I'm going to go -10. I think that's what we did on the back. I'm going to make sure that the origin is hidden. And once again, rotate this around and create some lofts between. Now we can't use something like a patch here because the patch needs to have a complete boundary, whereas loft will let us have it open. It doesn't really need that boundary. So we're going to right click and repeat. This should just be 2 selections here. And now we've built in the upper and lower portions. Now, once again, this is not perfect. There are things that we sort of didn't do just because the intent is not to model this entire car. But what I wanted to show you is that we can carry on with the geometry we had. We can use these 3D curves to help build out the shapes. It's a little bit tricky for us to do a change in direction like this. You'll likely find that you would want to go back and potentially make some changes. So for example, with this sketch here, if I were to activate this handle, let's go ahead and move it just slightly and right click and say OK. We're going to select that endpoint of the handle. And if we are to pull this in, which means it's going to reduce the tangency influence, reduce the weight, what that's going to do is it's going to tighten up that transition. So when we finish the sketch and it rebuilds the surface, what we should see is that the reflection, the light, ends up getting a bit tighter, a bit more defined up here, and it sort of fades away back here. So if you go to inspect and you turn on zebra stripe analysis, for example, and we add some horizontal lines, what you're going to see is that if we increase the repeats, these lines are going to get tighter together up front, and that's because we reduce the influence that that tangency handle had. We, instead of saying it's going to pull a full amount, let's say 1, it's only pulling maybe 50% or 25%, whereas the one at the back is still very gradual. So if you wanted to play around with these shapes a bit, you could always go back in and you can manipulate those handles. So for example, if we did the same thing to the one on the back, so it's going to be this handle, again, move, going to move it just slightly, and then right click and OK, select that end handle. And now again, if we tighten up that transition, what we're doing is we are changing, fundamentally, we're changing the way that that surface is built. So by tightening both of those up, we can now see that the zebra stripes are staying in line, which means that if we turn the analysis off, we have a tighter transition in that area. Now, it does have negative effects. You can see what happened. That back edge is now wavy, where before it was nice and smooth. So because we're doing this in 3D, you would need to really take some time and play around with these handles to make sure that you do still have the proper curvature in all directions. And for me, that still comes back to doing it in 2D. I still like to come back to viewing each of these as 2D splines and playing around with them in 2D, and then manipulating them, looking from the side and looking from the front or the top or bottom. So at this point, once again, I'm going to say it, I'm not planning on carrying on with this Fender. I don't plan on doing any more with it. I know I'll probably get more questions and people want to see the entire thing modeled. The truth is that to model a car like this takes quite a bit of time. It's going to take many more hours. We did the Ferrari 301 series. We did some on a Subaru WRX. We have the Porsche 911 series, which was 10.5 hours. That was 6.5 hours on the body using forms. You can multiply that by 5 if you try to do it with surfaces. This Fender would have taken 10 minutes for me to do as a form, but instead it's going to take, 45 minutes to do as a surface with sketches. Even if you're doing 3D sketches and 3D splines, which can be a bit quicker, it's still going to take a considerable amount of time to model a car in this way. And because the surfacing tools in Fusion, they're not true Class A surface tools, they do have some limitations with things like patch not being able to work on open selections, or having issues where you can't use a sweep with curvature continuity. You can't say it's tangent or curvature continuous. It means that we have to make design decisions along the way that complicate the process. So for me, I don't think it's worth the time to go down that route. I want to focus on surfacing tools that apply to a whole range of things rather than just car modeling. But if you have any questions on this, please let me know. I'll do my best to answer them. And as always, thanks for watching, and we'll see you in the next one.